Okay, welcome to the video. It's morning time here, so good morning. I'm here to give you some overview videos of Chapter 5, and this is the first one from Chapter 5, so welcome. This video starts with just a sort of an overview of optical fibers, and I've written down a lot of the things that I need to write on this slide already to save time. But basically, as we start talking about optical fibers, we'll first give this overview of the different fiber types and materials. We'll then give an overview of the loss mechanisms, including absorption, scattering, and geometrical effects. And finally, we'll go on to look at the mode structures of fibers used in telecommunications systems. And we'll see that Chapter 4, our work in Chapter 4 on understanding the mode structure of a slab waveguide will help a great deal in understanding the mode chart or the mode diagram for optical fibers. And we've already done a lot of work with dispersion, and so that will also help us understand the different types of optical fibers. So let's start with the overview of the different types of optical fibers here in this video. We can characterize fibers various different ways. We can characterize them according to mode structure. And we can say we have two main types of fibers, single mode and multimode. We can also characterize them according to their index profiles. And we can generically say we've got step index and graded index fibers. Okay. We've talked about graded index fibers when we talked about a grin lens. We talked about a graded index lens. The graded index fiber is basically the same idea, typically a parabolic index profile, just like the grin lens that we talked about from Chapter 2. And we will see that graded index fibers are used most often in the multimode variety, and that step index fibers are used most often in the single mode variety. We have various materials that we make optical fibers out of, including most commonly glass, but there's also various combinations of glass and plastic. PCS is the notation your author uses for polymer-coated silica, and POF for plastic optical fiber. So in polymer-coated silica we have a glass core with a plastic cladding, and in plastic optic fiber the whole thing is plastic. Okay. It turns out the index deltas tend to be on the order of 1 to 2% in glass fibers, whereas the index deltas for plastic optical fibers turn out to be 4 or 5%, much larger. In general, glass fibers have much lower loss than plastic, and so are much more common. The most common types include single mode for long distance, and these are usually step index, and the core diameter is typically on the order of 8 to 10 microns. In the multimode world, multimode fiber, these are usually grins. And we'll see actually an equation later on this chapter that shows that the pulse spreading due to multiple modes, and we talked about that in a previous chapter, and it was called multimode distortion, but it does give a pulse spreading delta tau per unit length. And if you go ahead and make multimode fibers out of that have a step index, it turns out that the multimode distortion is much larger than if you make a multimode fiber with a grin. index profile. And so grins usually dominate the multimode fiber. And the core diameters is typically anywhere from 50 to 100 microns. And we saw that in Chapter 4, where we know that the thicker the waveguide, the more modes it will support. That was our mode diagram. That's the diagram you're making on the spreadsheet. Some notation to know and to recognize when you see it. If you see, typically you'll see two numbers, for example 50/125 would be a multimode fiber with a core diameter of 50 microns and a cladding diameter of 125 microns. So and I think that it's usually only used for multimode fibers because step index are almost always the same. 8 to 10 micron core with a 125 micron outer diameter of the cladding. And so typical multimode fibers include 80, 125, 200, 230, etc. Okay, and that tells you that characterizes the fiber core diameter and cladding diameter. Okay, I'll stop here on this video. The next video I'll talk about loss mechanisms. Thanks.